Assalamu alaikum. This is Adeel Khalid, and today I'll be talking about validity and reliability in research methodology. So, the whole presentation would consist of three elements, starting from validity and followed by reliability, and at the end, there will be a summary. So, first of all, when you do a quantitative research, you must consider the reliability and validity of your research method and the instruments of the measurement. So, what validity is? In general, validity is an indication of how sound your research is, and more specifically, validity applies to both the design and the methods of your research. And in research, validity is the data collection, means that your finding truly represents the phenomena you are claiming to measure. Valid claims are solid claims. So, validity is a test of how well an instrument that is developed measures the concept and it's intended to measure. So, validity tells us how accurately a method measures something. If a method measures what it claims to measure and the results closely correspond to real world values, then it can be considered valid. So, there are four types of validity: construct validity, content validity, face validity, and criterion validity. When we have to measure the test and test measures the concept that it's intended to measure, then we can say this is the construct validity. And if is the test fully representative of what it aims to measure, then it can be categorized as the content validity. And when does the content of the test appear to be suitable to its aims, then we can call it as face validity. And if it answers do the results correspond to a different test of the same thing, then it can be entertained and criterion validity. So, construct validity. Construct validity is about ensuring that the methods of measurement matches the construct you want to measure. If you develop a questionnaire to diagnose a depression, you have to make sure that your instrument that you are using for the research should consist of the elements that are related to depression. And we have to answer this. Does the questionnaire really measures the construct of depression? And is it actually measuring the respondent's mood, self-esteem, or some other construct? So you must ensure that your indicators and measurements are carefully developed based on relevant existing knowledge. So the questionnaire must include only relevant questions that measures known indicators of depression. So the content validity. Content validity assesses whether test is representative of all aspects of the construct. So the content of a test, survey, or measurement method must cover all relevant parts of the subject it aims to measure. And if some aspects are missing from the measurement or if irrelevant aspects are included, the validity is threatened. So, for example, a mathematics teacher develops an end of semester algebra test for her class. The test should cover every form of algebra that was taught in the class, and if some type of algebra are left out, every concept needs to be tested in order to get the insights of the class that whether they have got they have learned what they were taught, and results may not be accurate indication of students understanding of the subject. What if teacher puts in the history questions or the English questions? the results are no longer a valid measure of algebra knowledge. Having said that, teachers should only be testing the students on the basis of algebra, keeping the fact in mind that that particular test should contain every concept in it in order to validate about the students that they learned what they were taught. Face validity. Face validity considers how suitable the content of a test seems to be on the surface. It's similar to the content validity, but face validity is more informal and subjective assessment. So for example, you create a survey to measure the regularity of people dietary habits. You review the survey items which ask questions about every meal of the day and snacks eaten in between for every day of the week. On its surface, the survey seems like a good representation of what you want to test, so you consider it to have high face validity. Let us take another example right after it. As face validity is a subjective measure, it's often considered the weakest form of the validity, and however, it can be useful in the initial stages of developing a method. So, the criterion validity. To evaluate the criterion validity, you calculate the correlation between the results of your measurement and the result of the criterion measurement. If there is a high correlation, this gives a good indication that your test is measuring what it intends to measure. So, what is criterion? Criterion is an external measurement of the same thing. It usually an established or widely used test that is already considered valid. So, for example, a university professor creates a new test to measure the applicants enrolled in the English writing ability. To assess how well the test really does measure students' writing ability. In order to do that, teacher will find an existing test that is considered as a valid measurement of English writing ability and will give it to the students, and in return the feedback would be compared with the previous one and the current one. Both of the tests would be considered to validate. So if the outcomes are very similar, the new test has a high criterion validity. So reliability. Reliability tells you how consistently a method measures something. When you apply the same method to the same sample under the same conditions, you should get the same results. If not, the method of measurement may be unreliable. So there are four types of reliability. Number one, the retest reliability, the same test over time. Second is iterator, the same test conducted by different people. The parallel forms, different versions of the test which are designed to be equivalent. Number four, the internal consistency. The test retest reliability. The test retest reliability measures the consistency of the results when you repeat the same test on the same sample at a different point in time. You use it when you are measuring something that you expect to stay constant in your sample. For example, a test of the color blindness for a trainee pilot applicants should have high test retest reliability because color blindness is a trait that does not change over time. So why is it important? So many factors can influence your results of different point in time. For example, respondents might experience different moods or external conditions might affect their ability to respond accurately. The test retest reliability can be used to assess how well a method resists those factors over time. The smaller the difference between the two sets of results, the higher the test retest reliability would be. So, how to measure it? So retest reliability can be used to assess how well a method resists these factors over time. The smaller the difference between the two set of the results, the higher the retest reliability would be. For example, you decide a questionnaire to measure the IQ of the group of participants, a property that is unlikely to change significantly over time. You administer the test to months part of the same group of the people, but the results are significantly different. So the test retest reliability of the IQ questionnaire is low. So how to improve the test retest reliability? When diagnosing or designing a test of the questionnaire, try to formulate questions, statements, and tasks in a way that won't be influenced by the mood or concentration of the participants. When planning your methods of data collection, try to minimize the influence of external factors and make sure all samples are tested under the same conditions. Remember that changes can be expected to occur in the participant over the time and take these into account. Inter-rater reliability. Inter-rater reliability, also known as the inter-observer reliability, measures the degree of agreement between different people observing or assessing the same thing. You use it when data is collected by researchers assigning ratings, scores, or categories to one or more variables. So, for example, in an observational study where a team of researchers collect data on classroom behavior, interior reliability is important. All the researchers should agree on how to categorize or rate different type of behavior. People are subjective, so different observers' perceptions of situation and phenomena naturally differ. So reliable research aims to minimize subjectivity as much as possible so that a different researcher could replicate the same results. When describing the scale and criteria for data collection, it's important to make sure that people will rate the same variable consistently with minimal bias. This is especially important when there are multiple researchers involved in the data collection or analysis. So, how to measure this? To measure the inter-rater reliability, different researchers conduct the same measurement or observation on the same sample. Then you calculate the correlation between the different set of results. If all the researchers give similar rating, the test has high inter-rater reliability. For example, a team of the researchers observed the progress of the wound healing in a patient. To record the stages of healing, rating scales are used with a set of criteria to assess various aspects of the wounds. The result of different researchers assessing the same set of patients are compared, and there is strong correlation between all set of results. So the test has high inter-rater reliability. So improving retest reliability can be done by clearly defining your variables and the methods that will be used to measure them. Develop detailed objective criteria for how the variable will be rated, counted, or categorized. If multiple researchers are involved, ensure that they all have exactly the same information and training. Let's move towards the parallel form rating. Parallel form reliability measures the correlation between two equivalent versions of a test. You use it when you have two different assessment tool or set of questions designed to measure the same thing. Why is it important? If you want to use multiple different versions of a test, for example, to avoid the respondents repeating the same answers from memory, you first need to make sure that all the sets of questions or measurements give reliable results. And for example, it's the fact that in educational assessment, it is often necessary to create different versions of the tests to ensure that students don't have access to the question in advance. Parallel form reliability means that if the same student take two different versions of a reading comprehension test, they should get similar results in both tests. So, for example, a set of questions is formulated to measure the financial risk aversion in a group of respondents. The questions are randomly divided into two sets, and the respondents are randomly divided, and both groups are asked. Group A, Group B, and Group A has to take test A first, and then the Group B has to take the test B first. The result of the two tests are compared, and the results are almost identical, indicating high parallel forms reliability. So, to improve the parallel form reliability, ensure that all the questions or the test items are based on the same theory and formulated to measure the same thing. Internal consistency assesses the correlation between the multiple items in a test that are intended to measure the same construct. You can calculate the internal consistency without repeating the test or involving other researchers, so it's a very good way of assessing reliability when you only have one data set. And why is it important? When you devise a set of questions or rating that will be combined into an overall score, you have to make sure that all the items really do reflect the same thing. If responses to different items contradict one another, the test might be unreliable. So, to measure the customer satisfaction with an online store, you could create a questionnaire with a set of statements that respondents must agree or disagree with. Internal consistency tells you whether the statements are all reliable indicators of customer satisfaction. And how do we measure that? Two common methods are used to measure the internal consistency. Number one, average inter-item correlation. For a set of measures designed to assess the sample construct, you calculate the correlation between the result of all possible pairs of the items and then calculate the average. To split half reliability, they randomly split a set of measures into two sets after testing the entire set on the respondents. You calculate the correlation between the two sets. For example, a group of respondents are represented with a set of statements designed to measure the optimistic and pessimistic mindsets. They must rate their agreement with each statement on a scale of 1 to 5. If the test is internally consistent, an optimistic respondent should be generally give high rating to optimism indicators and low rating to the pessimism indicators. The correlation is calculated between the responses to the optimistic statements, but the correlation is very weak. This suggests that the test has low internal consistency. So, in order to improve the internal consistency, take care when devising questions or measures. Those intended or reflect the same concept should be based on the same theory and carefully formulated. So, if you have to choose that which reliability actually applies to your research, then here is the key. When measuring a property that you expect to stay the same over time, then you should go for the test-retest reliability. And when multiple researchers making observation on the ratings about the same topic, then you should go for iterator. Using two different tests to measure the same thing, you should again go for iterator. Using a multi-item test where all the items are intended to measure the same variable, then you should go for internal consistency. So let's have a quick summary of the concept. Okay, so let's play a quick dart. Here you can see that target 1, we have to make sure that we hit the bullseye in order to be reliable and valid, as our main objective is to hit the bullseye. So we'll try our luck in this. Here you can see that we have missed the bullseye, but still we are putting it somewhere at the same position. We are consistent, but we are not approaching the target line, that is the bullseye. So we are reliable, but we are not valid. And let's try our luck once again. Here you can see that all the targets are, all the the darts are missed and the targets have been missed. So we can say that we are not reliable, not even valid. So now, let us try once again. So here you can see that we have hit the 3 shots onto the bullseye. So we can say that this is reliable as well as valid. Thank you so much for watching this video, and if you have any questions to ask, you can simply write down in the comment section below. Allah Hafiz.